3 from the 2016 paper for Dynamical Systems and Chaos. 3a, we've got a polar system and we want to prove that there exists a limit cycle. And question 3b, we have a Cartesian system and we want to again prove that there exists a limit cycle and find a trapping region for that limit cycle. So for 3 part A, we're given it in polar form, so we have dr by dt and d theta by dt. The origin is the only critical point because d theta by dt is 1, so it's always positive. If we put r is equal to 2, then you can see that the plot of 1 plus 0.9 cos theta minus 4, here is the plot here, and you can see that that is always negative. So dr by dt is negative on r equals 2. How do we plot that curve? Well, we just use easy plot. So we do easy plot, and the curve is 1 plus 0.9 times cos of theta, so we'll just use x and then take away 4. And we'll plot that for 0 to 2 pi. Oh, we have to do declare x to be symbolic. So here is the plot, and again you can see that this is strictly negative. Okay, which is shown here. So that one's negative. So dr by dt is negative when r is 2. If we take a value r is equal to the square root of 0.05, and we take the square root because this then makes this a nice number, then we can check that dr by dt is positive. Again, we can use easy plot, and you can plot the curve here, and here you can see it's positive. So dr by dt is positive. Therefore, a suitable region, if we take r is greater than the square root of 0.05 and less than 2, then we have a region without any critical points, because the origin is the only critical point, because d theta by dt is positive. So therefore, there has to exist a limit cycle by the corollary to the Poincaré-Bendixson theorem, so that there is a trapping region there. Okay, for part B, we have this Cartesian system. We're given our Lyapunov function v, so we just substitute that to find dv by dt. So dv by dt is dv dx dx dt plus dv dy dy dt from the chain rule. We substitute the values in, and therefore dv by dt is equal to this expression. And again here we can use MATLAB, so we can use easy plot to plot these curves. The red curve here is 4 minus x squared, so it's x squared plus 4y squared is equal to 4. And if we take x squared plus y squared equals 1, you can see it lies inside this curve, and inside this curve the x squared plus y squared is 1. dv by dt is going to be positive. So dv by dt is positive, so the flow goes out of this curve here. So that's with x squared plus 4y squared is less than 4. So the v dot is positive in here, and then outside here, again we can show that dv by dt is negative out here. So the flow goes in. So that means that this then is a stable limit cycle. This concludes the solution for question number 3.